This means
Okay, so from our yesterday class, we discussed about OSI layer model. We have discussed what are the 7 layers of OSI model, how are they useful for a network engineer to separate a issue into multiple smaller layers. We talked about mapping the OSI layer model to the TCP/IP model. I hope there are no questions from that. So today we will discuss about network topologies. What are different types of network topologies and how are they being used in the real world? So we will take a few examples of a real-time network topologies, and then we will see how it is different and where it is used in the real time. Okay. So I'm going to start with a simple home network. It could be an office setup, or it could be a simple internet setup in your home network. So in your home network, so what you will be seeing in your home network, so you will be having your laptop or mobiles, end user devices like iPads, anything, they all will be connected to one single router, which is acting as your there will be one router. The ISP provider will be coming to when I mean ISP, the vendor who is providing you the internet services like your Spectrum, AT&T or Verizon, or whoever is providing the service for your home network. It could be a charter, it could be any other service, right? So they will come to your house, they will they will install a router, and this router will also be acting as access point. Access point is nothing but sending the wireless signal to your machines, right? So you will be wirelessly connected, or you can also do wired connection, but your devices will be connected to either over wireless or through wired. It will be connected to this router, and this router will be having a connection to the outside of your house. Whoever is your provider, they will be having a gateway or a modem at the end of the street or the community or that specific location. All these routers will have a fiber connection going to the ISP connector, or you can location router, and from ISP location router they will be connected to their data center, whichever. For example, if you are using AT&T, that will be connected to the AT&T network, and this AT&T network will be connected to the internet. Basically, from here it's all open internet. So internet is nothing but the collection of service providers, right? The collection of AT&T, Verizon, Cogent, Level 3, all of these service providers, they are combinedly called it as internet. So from your home network perspective, you will be from till here you will be owning it. Till here you will be owning it in your home network. From here, the ISP will take care of it to send you out to the internet. So all you are doing is you are installing a router which will be having an access point for the wireless signal to be transmitted. Your device will be connected to this SSID. SSID is nothing but the Wi-Fi name. And once you have that, it will be having a connection to the ISP. In this case, the router is also acting as your gateway. When I mean a gateway, I mean to say it's a layer 3 device which is providing the a route outside of your network. Meaning, like, if this device want to go out to the internet, this is the path to go out. So that is called the gateway. The gateway is nothing but the device which is providing the reachability outside of its network is called the gateway. Just think about like your house. Your house has the main door, which is the gateway to the internet. Similarly, when you have a connection that is making you to reach out to the internet, that is called as your gateway. That is your layer 3 hop. Okay. Any questions on the home network topology? Okay, this is pretty simple. Every home has it, so it may be easy to relate. Now let's see in a little bit a bigger network. Maybe let's take a store with 2 or 3 computers, right? Maybe let's take a small shopping store. Maybe I'll take Macy's. Okay. So now let's look into the Macy's network. So I'm going to take a small store with the Macy's network in a single location. We are not talking about the communicating of different Macy's in different branches. We are not talking about that. But let's take a simple Macy's building that you go for shopping. Okay, let's take that network as an example. So what they will have usually, they will have 3 or 4 counters, the billing counters. Let's take 3, and they will have basically a backend server room. They will be having the access points for the Wi-Fi signal in the store. They will be having a printer, maybe. What else? They will also be having some fire alarms. They will also be having emergency telephone or something like IP phones like that, right? So let's name them. Billing counter 1 is nothing but a laptop, right? Billing counter 2, billing counter 3, and then they will be having access points for the wireless signal. And they will also have a printer. And then they will be having a telephones, fire alarms, etc. Just I gave an example of all these devices will be there in their store. So now these laptops, they all should be plugged in to the server room, which will be having a switches. So they will run the cables from their computers to a switch here. So in this server room, there will be a switch. And the printer will go to the switch. 1 second. Sorry, guys, that's an important call I had to take. So yeah, coming back. So the building counter 1, building counter 2, building counter 3, they all will be connected to the switch, and then the printer will be connected to the switch as well, right? The access point 1 will be connected to the switch. AP2 will be connected to the switch. AP3 will be connected to the switch. Similarly, the telephones will be connected to the switch. Firearm will be connected to the switch. So switch is nothing but the layer 2 device, which will be connecting all these devices locally in the machine, right? I mean, locally in the network. So all of them can be connected to a one single switch, which is acting as your access layer, or you can consider it as uplink device. And this switch will be connected to the router. And the router will be connected to the AT&T connection again. That is pretty same. So from here, it will be connected to the AT&T, just like your home network. It will be connected to the service provider AT&T. So if you would have observed, because the building is bigger, we got 3 access points, right? Because you got the bigger network, you got 3 access points. Access point 1, access point 2, access point 3. They will be sending the wireless signals throughout your floor, the Macy's floor. Whenever you are roaming, you will get the Wi-Fi with these access points. And the building counter 1, building counter 2, building counter 3 are the laptop or the PCs. They will be connected to the switch, and they can intercommunicate between them. And also, if they wanted to go out of the network, they will go to the router and then go out to the internet. And then, I mean, there is the internet. So the thing that you should observe is a switch is like a device which is interconnecting all the devices in the LAN network, local area network. So with this switch, these are all able to interconnect between them. All these devices are interconnected using the switch. If this devices want to go out of the network, they will be using the router help as the gateway, and then they go out to the service provider and they go out to the internet. But there is an issue with this design. There is a problem with this design. What is the problem, guys, with this design? What is the problem?
What if the AT&T goes down?
Failover mechanism.
Yeah, so if the switch go down, if the router go down, if the AT&T go down, there is no backup. If the switch go down, entire devices will lose the connection. If the router go down, entire internet is gone. If the AT&T itself go down, entire thing is gone, right? So there is no failover mechanism. There is no redundancy in the path. We are in a place where we are single threaded, meaning we don't have backup plan for our network. So that is the problem. So to avoid this, we will be coming with an idea of having a redundancy or high availability or failover mechanism. These words are interchangeable. So what we will be doing is we will be doing a pair of switches, pair of routers, pair of service providers to have that high availability in the network. So if an ideal network will look like something like this. So PC1 will be connected to the switch 1, PC2 will be connected to the switch 2. Similarly, switch 1 and switch 2. Switch 1 and switch 2. Switch 1 and switch 2. Switch 1, switch 2. So here everything is a full mesh. So now the switch 1, switch 2. Now this is a router 1, router 2, and this is AT&T, and this is Verizon. And the links will go is router. Okay. So basically, if the PC1, from here, if it wants to go to internet, the PC1 will go to switch 1 go to the R1, and R1 go to the AT&T. That is the primary path. Let's say that's the primary path. If switch 1 go down, there is a backup link going to the switch 2. Switch 2 can go to R1, and then R1 to the AT&T. And what if R1 also fails? Here to switch 2 to R2, and R2 to Verizon. So you have multiple paths to go out to the internet when you have this sort of redundancy. So that is how the corporate networks like Macy's and other stores run their network, by having redundancy in play. Because if their internet go down, the customer billing activities will be stopped, and it's a loss of business. So they try to put two providers. If the one go down, they have the backup path immediately. And how we achieve that backup path, how we achieve that redundancy will be defined with routing protocols. We will discuss more when we talk about our routing mechanisms and such like that. But think like having redundancy in the path, meaning if one device in the uplink go down, we will have a backup path in the network to have that failover mechanism in play. So this is how a store network will look like. Any questions, guys? Am I making sense here, guys?
Yes.
Yes, Ravi.
Yes, Ravi.
Okay. We'll move on to the similar setup, but let's say we have now, let's take a hospital network now. Let's say there are multiple buildings. Now we talked about a store which has a couple of building counters, some access points, some printers and fire alarms, right? But now let's take two or more buildings in a hospital network. Let's say there are 3 buildings, and how do we interconnect them? How do we make sure we have interoperability between them, and how the communication works? Now let's take I'm going to take a hospital environment. Okay, now I'm going to take building 1, and then building 2, and then building 3. Okay. Okay, so I have 3 buildings. Now I should be making 2 things. One is communication inside the same building. So inside the same building should work. And then the communication between the buildings should work. And the communication from the building to the internet should work. So total 3 type of transactions should go. One is communication inside the building. The other one is communication between the buildings. And one is communication from buildings to the internet. So total 3. So if we talk about inside the same building, that is called LAN, right? I mean to say that is called inside the same building, inside the same network is local to the network, correct? So then what I'm going to do is, I'm going to take a building 1, and then building 2, and then building 3. Okay, so I have 3 buildings. Now let's say we have 2 or more buildings in a hospital network. Let's say there are multiple buildings in a hospital network. So how do we define the LAN? let's say I'll put 2 switches inside that building, which are acting as my access layer switches, meaning my endpoints. Let's say my endpoints, when I mean endpoints, I'm talking about printers, laptops, PCs, fire alarms, access points, anything can be an endpoint. Okay. And these all will be connected to the switch 1 and switch 2 in a redundant fashion. Right, so every building will have 1 switch pair. Okay, so that is how the building connectivity works inside that, right? So if this device want to communicate with other device, it will go to the switch, and switch will switch between them and communicate inside the same, and this is called LAN, local area network. And this is another LAN, and this is another LAN. Okay, think about like that. So now I wanted to make this building 1 and building 2 communicate. So what we're gonna do is, from this switch, we're gonna bring a router 1 and router 2, router 1 and router 2, router 1 and router 2. Each building we will have router 1 and router 2, and we will have a WAN connection between them. When I mean WAN, it means wide area network. So meaning when there are 2 buildings in 2 different locations, or which are widely separated, when we run a cable, a fiber cable between them, that is called a WAN link. So what I'm going to do is, I'm going to run a fiber link. The fiber link between router 1 to router, and then this router to this router, this router to this router, and then this router to this router. Similarly, from this router to this router, and this router to this router. So between the router 1, router 2, I'm going to make a full mesh between this router to this router, and this router to this router, and this router to this router. So there is a communication going on between the router to router, which is called WAN, wide area network. So inside the same building, that is called local area network. When I'm communicating between the buildings, that is called wide area network. So this can be achieved again by using routing between them. Like we can use different protocols. One example I can give is like MPLS. You might have heard fancy words like SD-WAN, software defined WAN. That is another technology. There are a lot of things like extending pseudo lines, but all it's doing is running a fiber. They will take a fiber link and they will run all the way to the other location by running a fiber cable between them. So that is the WAN portion of connecting the buildings. So inside the same, this is very similar to the mazes example that we took earlier. So that is considered as LAN, and you are making the LAN to LAN communication by having a wide area network in play, that is called WAN. So this is how you will connect multiple buildings. So inside the same building, when you talk, that communication can be called as local area network. But when you're communicating between the buildings, that is called wide area network, and you are making the buildings communicate between them by having a fiber link connected between them. So this is how a hospital network with buildings spread across looks like. And if they want to go to the internet, again, it's the same. Every location will have their internet, AT&T or Verizon kind of service providers. And that part is very same as the mazes we have seen. Every router will have again a service provider 1, service provider 2. If the primary service provider go down, the secondary service provider will be there. So when someone is talking about WAN, think that they are talking about your network in 2 different locations they are trying to connect. That is called WAN. But if someone is talking about internet connection, that means that for that specific location, you are having internet connections You are paying for the internet bill and you're getting internet connection. That is separate than WAN connection. A WAN connection is connecting between two different networks of your same, connecting two different networks that you own, but which are in different locations. Is this clear?
Yes, sir.
Yes, Ravi.
Okay. So now let's see a data center network. Now let's see the how a big enterprise network look like when you have multiple buildings in a specific location. Now we have seen multiple buildings in different locations connecting via WAN, but how do we connect multiple buildings in the same location? I mean to say, you have multiple floors in a building and you have multiple buildings in a single location. You don't need to have a WAN layer there, but you have to have a full mesh kind of topology to get this functional. That is called 3-tier architecture, core distribution access layer. Let's talk about that now. So now, let's take again, I'm going to take 3 different buildings or 3 different floors, however you want to name it, that's fine. I will be having 2 switches. Just an example, I'm taking 2. It can be more than 2 switches, but for ease of understanding, let's take 2 switches per floor. And these will be connected to pair of distribution switches and pair of distribution switches. And then they will be connected to a core switch 1 and core switch 2. So this is called access layer switch. Access switch 1, access switch 2, access switch 3, access switch 4, access switch 9, access switch 6. This is called distribution switch 1. And then core switch 1. Core switch 2. So the access switch will be paired to DS1 and DS2. Access switch 2 will be pairing to DS1 and DS2. Access switch 3 will be connected to this one and this one. Can also have connections to DS3, DS4, and this can have connection to this one and this one, and then this one, and then this one. So we connected to this one. Okay, so now in this floor, hundred user devices are there. In this floor, 500 user devices. This floor, 100 user devices. So if you observe, So the floor 1 will have 100 user devices, floor 2 will have 500, and floor 3 will have 100 devices. So now when the user is coming, so the user device, let's take one device as an example. Out of 100, I'm taking one as an example. It can be paired with access switch 1 or access switch 2. The user can go via this link or this link, and then he can choose via this link or this link. He can from here. Okay, let me complete this as well. Here, change the color. The DS will go to the core switch 1, DS will go to the core switch 2, DS2 will have core switch 1, core switch 2. So does it applies for DS3, 4. So the reason why we have these many links is to have the redundancy again. If one switch go down, there should be a redundancy in terms of having communication. There should not be breakage in the communication. So out of 100 devices, let's go back to these 100 devices again. So the switch, this port can be using this switch port, or it can be using this switch port. From here, it can pick either DS1 or DS2, right? And then from DS1, it can go to the core switch 1. And from core switch 1, it can go to the router. And then the router here, which can be AT&T or Verizon, and it can go out of the connection. So by having the distribution layer is the layer which is connecting these floors. The distribution layer is the backbone layer that is connecting the floor to floor communication. So if this access switch, if 100 user wants to connect to these 500 users, their path is going from here to the DS1, going to the AS3, and then coming to the switch. So for inter-floor communication, inter-building communication, the distribution switches are used. But if this switch wants to go out to the outside of the gateway, that means that it can go all the way to the core switch, go to the router, and then go out to the internet, right? So if this entire thing want to communicate something out of another data center, again, there will be having a core, there will be having distribution switches, there will be having access layer, and there will be a router to router WAN link again. So, but when you have multiple buildings or multiple floors in the same location, you will be having the distribution layer, which is interconnecting the floors or buildings, and the cores which will be acting to connect the routers, and then they will provide the WAN connections, and also they will provide the internet connections. That's what the core switch will do. And the access layers which will be used to connect to the endpoint devices. So if you have a big network with comprises of multiple floors, you will be having 3 layers. One is access layer, one is distribution layer, and the other one is the core layer. The access layer will be used to connect all the endpoint devices. The distribution layer will be used to connect the connection between the floors by having acting as the backbone. And the core devices will be used to connect the layer 3 connectivity like routers, firewalls, WAN connections. Everything will be done by the core switches. Any questions on this 3-tier architecture?
Hi, Ravi. Can you repeat once again the access switches, distributed switches, and core switches?
Access switches will be used to connect the endpoints. All the endpoints will be connected to the access layer switches. Distribution switches will be acting as the backbone in connecting the different floors. If you look at the diagram, the distribution switch is connecting the floor 1 and floor 2. They are acting as the middleman to make the floors communicate between them. So if the user 1 in floor 1, if they wanted to connect with the user 2 in floor 2, their only path is to go via distribution switch. So the distribution switches are the middleman that is connecting between the floors.
Okay.
And the core switch is the layer 3. When I mean layer 3 again, the gateway, the core 3 will be used to connect outside of the network, like your WAN connections, like we discussed earlier, or it can also create connections to the service provider like AT&T and Verizon.
Okay. Thank you.
So now the floor 1 and floor 2 will become the WAN connections.
No, because the distribution switch can be able to communicate between both of them. This is all considered as one single LAN. So if your buildings are geographically separated, meaning if one building is in Chicago, another building is in SFO, they are separated by thousands of miles, correct? Then they will be called as WAN connections between them. They needed a WAN connection between them. But in my example, I can run switch 1 cable to the DS in the same location, and then it will be able to connect to the other switch. So this is just an distribution switch that is connecting both the floors or both the buildings inside the same location. That is called LAN.
Yeah. But in that case, building 1 and building 2 are we can connect through the wires, right? It's near to the locations build like. So then it can be a LAN too, right?
That's what I'm saying. I'm saying these two are these are all part of one LAN. Yes.
No, I'm talking about building 1 and building 2. You said building 1 and building 2 are connected with WAN.
Yeah, which are geographically separated. In my example, they are geographically separated. Building 1 is in different location, building 2 is in different location.
Oh, okay.
The sole purpose I brought the buildings is I meant to say I took two hospitals. Building 1 is a hospital 1, building 2 is a hospital 2. If I wanted to make them connected, I will be using a WAN connection between them. They are geographically separated.
But if the building 1 and building 2 are near, then it can be a LAN, right?
Yes, that's what I'm saying. Here, they're in the same location. These can be two floors or two different buildings. That's why they're part of one LAN.
Okay.
Hey, hi Ravi. Actually, here access switch 3 and switch 4, right? These two switches directly connecting to all the direct switches 1, 2, 3, 4. But access switch 1 and access switch 2 is connecting only to direct switch 1, direct switch 2. What is the difference between these two?
Because of having the capacity of 500 users, I need more uplinks. This is a great question. Your question is spot on. Because of 500 users, I need more capacity to go out.
Okay.
That's why I put 8 links.
Got it. Thank you.
But here and here is 100 users, and here is 100 user devices, right? That's why I don't need those many uplinks.
But the functionality is same, right? Access switch 3 and access switch
1. Functionality is same.
Yep. Thank you.
So we'll distribute the traffic for floor 2, right? Into 500 by 8.
Switches will automatically distribute the traffic. Yes.
Okay.
Yeah, but it was just more of like an intentional diagram there. It doesn't need to have a full mesh there. But I just gave that example that if I have 500 users, I can still have uplinks connected to all the uplinks so that I can distribute the traffic. But here, if I have only 100 users, I can still have the cross connection to DS3 and DS4. I mean, distribution switch 3 and 4. It doesn't really matter. You can still do that to have more redundancy in play. Okay, let's look into the last topology, which is a spine and leaf architecture, which is more suitable for the data center environments, not like hospitals, not like multiple floors, but we are talking about a big data center with thousands and thousands of servers. We need more capacity planning because of the scalability. I will give an example like a Netflix, right? So Netflix has a huge data center with thousands and thousands of servers sitting across, and they wanted to have intercommunication between them. In that scenario, we need to reduce the east-west traffic communication. Again, when I mean east-west traffic, let me explain what I meant here in a second. Any questions on this topic again before we move on?
No.
Okay. So instead of taking the 3-tier architecture, now we will take a 2-tier architecture, which is spine and leaf architecture. Let's say you have so I have 4 spines. Okay, so every spine, this is spine 1, this is spine 2, this is spine 3, and this is spine 4. And this is leaf 1, leaf 2, 3, leaf 4, leaf 6. So let's say an endpoint is connected here. Endpoint 1 is connected here. A PC1 or server 1 is connected here. And this server 1 wants to talk to the server in this. So this leaf will form a tunnel. This leaf will form a tunnel with this leaf directly by having the spine as the underlay connection. So there is a tunneling methodology that can be formed between leaf 1 and leaf 5. Let's say there is an EP endpoint wants to connect to here. There is a tunnel that will be formed between the leaf 1 to the leaf 6. So every leaf switch will form a logical tunnel to the other leaf in the network, so that the communication will be faster by having the series of underlay links. So you have these many links, right? The underlay you have, leaf 1 have 4 links to each spine, but there will be a logical tunnel that will be formed so that the communication between the east-west traffic will be faster by having the underlay connection and the overlay connection. So if you see from EP1, if you look at the routing table, it will directly show the next hop as the leaf 5 as the overlay tunnel. So when we talk about how to build a tunnel, we will know the more idea of how this works. So you have to keep in mind that the data center environments are built to have the east-west communication. When I mean east-west, the flow of the direction is what I'm meaning, east and west. So if one server wants to talk to other server, that means that the traffic is going from server 1 all the way tunnel to the leaf 5 via east and west traffic. But what if the EP1 wants to talk to something over the internet? Then it has to go to the spine 1. Spine 1 will be connected to the router and then go to the internet again. That is called northbound, southbound traffic, north and south, north to south, because the traffic is going from server from south all the way to the internet to the northbound, southbound. But if the server 1 wants to talk to server 4, it will be east-west traffic communication. So with this topology, with this number of links in the middle, you can have faster communication by forming the tunnels between the one leaf to the other leaf, which is a logical tunnel, which will make things faster when communicating in a data center. That is why the data centers will be using the tunneling methodology to make the communication faster between the servers. Is this clear?
In this case, leaves and spine are switches or
Yeah, these are all switches. Yes, there are different models of switches which has the big capacity. The spine will have 400 gig capacity of throughput in a single go. So it's like you downloading 100 movies in a single second. That much speed.
okay.
Yeah. Yeah, but these are switches. These are different models of switches which has like larger capacity. But yeah, still these are switches. They are capable of, I don't want to dig deeper into the underlay, overlay, what protocol will be used. It will be too much confusing because we are not there yet. But to make it detailed, the underlay can be a BGP protocol or ISIS, or it can be OSPF, the underlay. The overlay can be a VXLAN tunnel. But I did not go to the deeper because it is not the right point we talk about the protocol yet. Just understand there is a topology of spine and leaf architecture. It is used for having the faster communication between the servers inside the data center. That's what I wanted to get at this.
There will be no communication between leaves here. Will they only communicate through spines?
Spines are the backbone. But yes, from leaf to leaf, there is a communication. They will be using the spines as the backbone connection. Without the spines, there is no communication works. Let's do a quick round then. So, David, you there?
Yeah.
Okay, can you tell me what is the 3-tier architecture? Gayatri, what is the 3-tier architecture?
Sorry, sir. Come again. What is?
What is a 3-tier architecture?
It is basically LAN network, which has router and access points to routers, and then router through which we can get connected to the internet.
I want you to be more present in the class. Madhu, what is a 3-tier architecture?
Sorry, sir.
All right, anyone in the class, what is a 3-tier architecture?
Yeah.
It's an okay.
Okay, go ahead.
Well, it is like you taken in the data center example for the multiple buildings in an area. For the each floor, if we want to connect with the different floors, and from the user user devices to access switch to distribution switches, and distribution switches to core switches.
Yeah.
This will be a 3-tier architecture.
That is correct. Yeah. So when you have a big network and you wanted to intercommunicate between them, you will be separating them into 3 layers: core layer, distribution and access layer. Distribution layer will be connecting the floors by acting as the backbone or the middleman. Core switch will be used to connect outside of the network by connecting to the internet.
Gateway for service
Yeah,
provider.
on the gateway, and then the access layer will be connected to the endpoints. Okay. Pawan Kiran, can you tell me why spine and leaf architecture is used?
And internet.
Sir, I didn't get you.
Why spine and leaf architecture is used?
It's actually in 2-tier architecture, right? We'll use it in the 2-tier architecture.
My question is, why spine leaf architecture is used? Sai Varsha, why two-tier architecture is used?
To reduce the, to improve network efficiency, right?
To have the faster communication inside the same data center between servers, we will be using the spinal leaf architecture, which will provide more capacity. Okay, Pravalika, what is east-west traffic?
Here, the traffic will be moving from the access layer to access layer 1 to the other access layer 2. I mean, the traffic moves from PC 1 to PC 5. I mean, from east to west.
Understood. Yeah, east and west traffic is nothing but intra data center communication. Traffic from left to right or right to left inside the same data center is called east and west traffic. Rajshekhar, what is northbound and southbound traffic?
It is like trafficking between the internet and the spines, like in the data center.
Yeah, when the traffic is leaving outside the fabric, when the traffic is going out of the spine, going to the internet, that is called as northbound, southbound traffic. That is correct. Thank you. Vasant, can you tell me why do we need redundancy in the network?
Yeah, if there is any switch failure, then we use the another switch to access the internet or any devices.
Yeah, if there is any failure in the network, if one device go down, we should be having a failover mechanism to immediately take over that role. Okay, got it. Thank you. All right, guys, I'll stop it there. These are the network topologies that are used in the network. It could be a home network. It could be a small branch office network, small shop, or it could be a hospital with multiple buildings in different locations, or it could be a single building with multiple floors, or it could be a big data center. These are all the types of the networks that we're gonna handle, troubleshoot, fix the issues as a network engineer. When you get a job, you might be working in a small branch location, you might be working in a big data center. You will be fixing these problems, you will be fixing the communication issues inside your network. I'm gonna stop the recording there and leave the floor for any questions.
Yes, Ravi. Yeah. Here in 3-tier